So, all right, in this video, I'm going to be showing you how to know if a quadratic equation or function can be factorized. Before I proceed, it is very important to know that it is not all quadratic equation that you can factorize. All right, so if you are trying to factorize a quadratic equation and it seems as if it's not working, then you may need to use the discriminant to know if it can be factorized. All right, that's number one. Number two, please kindly subscribe to this channel to encourage me to produce more videos. Thank you. So how do you know if a quadratic equation can be what? Can be factorized? The first thing is for us to use the discriminant. The discriminant is defined as d is equal to b squared minus 4ac, right? So if d, which is equal to b squared minus 4ac, right, is equal to what? A perfect square. If it's equal to a perfect square, then that particular quadratic function or equation can be factorized or can be solved by factorization. But if it is not equal to a perfect square, then use another method. And if it is less than 0, like the previous one we did, then it implies that you make use of another method which may not be in the real domain. So now let's look at an example that we can use to know if this particular a quadratic equation can be solved by factorization. So for instance, let's say we are given, say, x squared minus what? X minus what? Minus 5, right, is equal to 0. So if you look at this particular problem, we want to check if this particular problem can be solved by factorization. The first thing we need to do is we recall that from the quadratic formula, ax squared plus bx plus c is equal to 0. So if you compare it, a in this case is equal to 1, because x squared here, the coefficient of x squared is 1, and the coefficient of x here is minus 1. So b is equal to what? Minus 1, and c is equal to what? Minus what? 5. So let's plug it into the discriminant. So we have d is equal to b squared, that is minus 1 square minus 4 into bracket. What is our a? A is 1, and c in this case is what? Minus 5. So let's do it. Minus 1 square, like I did, minus 1 square is the same thing as saying minus 1 times minus 1. So minus times minus is plus, 1 times 1, that is 1. So that is 1. Minus 4 times 1, minus 4. Minus 4 times minus 5, that is plus 20. Plus 20. So this will give us what? 21. Now let me explain something to you. 21 is not a perfect square, but it is greater than 0. So for the fact that 21 is greater than 0, this particular quadratic equation, we have two distinct roots. I mean two different roots. But the fact that it has two different roots, you can't solve it by factorization. So this is greater than 0. So I'm not even considering the fact that it is greater than 0. My focus is, can it be what? Solved by factorization. So since 21 is not a perfect what? It's not a perfect square. So then the quadratic equation. So therefore we can say that, let me still bring the, you can say that what? X squared minus x minus 5 is equal to 0 cannot, right, be what? Solved by what? Factorization. All right, so now let's look at another example. You can try it. You try to factorize it, but I can assure you won't be able to do that. So let's look at another example. So let's look at a case where we have, okay, x squared minus 4x, right? No, excuse me, x squared plus, x plus 5, right, is equal to what? 0. So in this case, if we compare the coefficient, a in this case is 1, b is equal to what? 1, and c is equal to what? 5. Wow. Okay. Well, this is not the actual question I want to use, but let's just look at this. I think so if you look at this, d is equal to b squared minus 4ac. So what is our b? That is 1 square minus 4 into bracket a, 1 into bracket c, which is 5. So if you look at this keenly, you discover that this is 1 square, that is 1. Minus 1 times, minus 4 times 1, minus 4. Then minus 4 times 5, that is minus 20. So 1 minus 20, that is minus 19. So this is now also a perfect what? Square. As a matter of fact, this is going to give you a complex root. It's not a real solution. It's just similar to the previous one. So let's now look at an example that will give us the kind of solution we are looking for. So let's look at this. So my conclusion for this is that what? I can x squared plus x plus 5 is equal to 0 cannot be what? Cannot be factorized. Okay, yeah. Even if you try it, it does not even have a real solution because it's less than 0. So let's look at this other one, this last example, which I believe this one we have what? X squared minus x minus 12 is equal to 0. So a in this case is 1, b is equal to minus 1, and c is equal to what? Minus what? 12. So now let's check the discriminant. So we have d is equal to b squared minus 4ac. So our b is what? Minus 1 square minus 4 into bracket. What is our a? A is what? 1, and our c is minus what? 12. So minus 1 square, that is 1. Minus 4 times 1, minus 4. Minus 4 times minus 12, that is plus 48. Don't forget, minus times minus is plus. 4 times 12, that is 48, right? So 1 plus 48, that is 49. And if you look at 49, 49 is a perfect square, which is what? Perfect what? Perfect square. So we can conclude, we can therefore say, therefore, x squared minus x minus 12 is equal to 0, right? Can be what? Solved, right? By what? By factorization. Okay, now let's now factorize it because of, just to prove to us that we can. So we have x squared minus x minus 12. So we have x squared minus x minus 12 is equal to 0. So what we need to do is to decompose it. So if we decompose, the coefficient of x squared here is 1. So if we decompose it, 1 times minus 12, that is minus 12. So we are looking for the factors of 12. That's 2 factors of 12. Such that when we add the 2 factors together, it will give us minus 1 because the coefficient of x here is minus 1. And when we multiply the 2 factors together, it will give us minus 12. The 2 factors I can think of is 3 and 4, right? So if we now, let's put some sign. That will be what? Plus 3 and minus 4. Plus 3 and minus 4 will give us minus 1. And plus 3 times minus 4 will give us minus 12. So we have plus 3 and we have what? Minus 4. So wherever we see minus x, we can replace it with plus 3 and then what? And minus 4. So we have what? X squared, right, plus 3x minus 4x, right, minus 12 is equal to what? 0. So the next thing is for us to decompose it. So if we decompose, what is common to both of them? That is x. So we have x into bracket x plus 3, right? X plus 3, since we were able to decompose this correctly, we are still going to be having x plus 3 here. So what we have outside is, what can we multiply by x that will give us minus 4? That is minus 4 times x minus 4. And minus 4 times plus 3, that will give us minus 12, will be equal to 0. So we have what? Since x plus 3 is common in these 2 times, then we can take it as 1. So we now have x and minus 4 outside as a term, x minus 4 into bracket x plus 3 is equal to 0. So the factors of that quadratic form equation is x minus 4 and x plus 3. Why the solution? So the solution, will now be what? X minus 4 is equal to 0, and what? X plus 3 is equal to 0. So if minus 4 comes here to become plus, so we have x is equal to what? 0 plus 4, and what? X is equal to what? 0 0 minus 3, because plus 3 is crossing to become what? Minus 3. So at the end of it, we have x is equal to 4, and what? X is equal to minus 3. I want to believe this video has helped someone. So what we have been able to do here is to at times, before you even begin to factorize a quadratic equation or function, first check the nature of the root, if it is actually factorizable. So if it is not, then you may have to use quadratic formula. And if it is a complex root, you can just conclude that it cannot be solved by factorization because it does not belong to the real domain, it's in the complex domain. All right, so thank you. Please kindly subscribe, share, and comment. See you in the next video. Bye.